So now we're going to discuss some of the material properties of these various insulation types. I'm going to break it down. So the two material properties that are most important when we're looking at insulation, R value is obvious. That's what we talk about most readily and commonly. And again, R value is a property's ability to resist heat flow through it. And if you look across this graph here, you will see, I've pointed this out again. I'm going to point it out one more time. This hasn't named all of, it's not a comprehensive list, but many of the products that are commonly used for insulation have very similar R values. They do function differently. They can. But the R values, if you ask what's the R per inch, whether you're talking about a higher density blown-in insulation, cellulose or fiberglass insulation, or you're talking about open-celled polyurethane spray foam, they have very, very comparable R values per inch, around 3.6, give or take a little bit. So that's not where you're going to see a performance difference, and there are other considerations that you may make. Ease of installation, time of year, scheduling for your construction process, budget, available qualified installing contractors. So which insulation you choose really will often or should depend upon factors other than the R per inch, because there's a lot of hype around new products or new iterations of products. Again, whether we're talking about fibrous products or foam or bats, they have very, very comparable R values per inch. So perm ratings I'm going to mention just briefly because being located in a hot, humid climate, we're sensitive to the potential danger of creating a condensation plane in our assemblies. And there are insulative materials which have very low permeances, perm ratings. And if you live in a hot, humid climate, or if you have internal sources of moisture which are not being actively controlled, then you should certainly be very cautious about putting an insulative or material or a vapor barrier in any of your assemblies. So basically, don't do it unless you know what you're doing. So let's look at open-celled spray foam. Open-celled spray foam, on average, all these values are on average, and there's a range depending upon manufacturer and actual product, and even depending upon the quality or of installation. But we're talking about open-celled spray foam. It's generally on the order of a 3.7 R value per inch. The product density, again, this is a low density polyurethane spray foam. It's generally half a pound per cubic foot. You sometimes hear it referred to as half pound spray foam. That's where that comes from. It's a density material property. It will not shed bulk water. It will take on water if it's exposed to it, and it will hold it even. It will function as an air barrier, however, again, depending upon the installation and the quality of the installation. And it can start functioning as an air barrier in the range of 3.5 to 5.5 inches. The permeance is good if installed properly, again, and I say good, it is vapor permeable. in the range, probably in the optimal range, 6 to 20 perms. So where would you find it? Where would you put it? On your underside of your roof decking, in the stud cavity of your walls. There's medium density close-held spray foam. It's got a density of 2 pounds per cubic foot. The R value is much higher as a result, and is on the order of 6 to even 6.5 or so R value per inch. It will shed bulk water, and it will function as an air barrier at about an inch up. It also has a much lower permeance, and it will act as a class 2 vapor retarder at 1.5 inches. And again, we see this in interior, but this walls, roof walls, and crawl spaces. But the permeance is getting low enough with closed-celled spray foam that you want to be cautious. In our climate zone, we generally recommend open-celled spray foam. Again, unless we have studied our building assembly and we understand our moisture sources, whether interior or exteriorly generated, and we want to make sure that we understand that and can effectively control them before we would recommend closed-celled spray foam in one of our assemblies in a hot, humid climate. Now, none of this holds true for dry climates. I shouldn't say none, but probably doesn't. So closed-celled high-density polyurethane spray foam has a density rating of about 3 pounds per cubic foot. It has slightly higher R value, but not much higher than the medium density. It will shed water. It's used on roofs and exterior as opposed to interior, and exterior walls. Functions as an air barrier at 1 inch, maybe even less, and has comes very close to functioning as a vapor barrier. The permeance ratings vary again, but are less than 1, which classifies it as a class 2 vapor retarder, but is again coming very close to acting like a vapor barrier. So rigid foam boards. XPS, extruded polystyrene, has an average R value of 5 per inch. You can get it in varying depths. Again, some manufacturers produce boards that have tongue and groove options, which makes for ease of using. This thermal control layer is an air barrier. The product density varies. It's not really to the point for this kind of product. The permeance is quite low. So again, we do want to pay attention to our assemblies when we use it. But generally, if there's a space behind on the interior side of your foam board, and the spaces can be quite small, it's not a concern. So when I say quite small, I mean if your building wrap or your fluid applied or peel and stick has some texture to it, that generally allows for enough space in order for this to not be a concern in terms of its permeance, low permeance values. It, like I said, it can function as an air barrier if it's taped and sealed. You would find this in your exterior roof walls or interior of your crawl space often if you've got a conditioned crawl. Another example of a rigid foam board is expanded polystyrene, EPS. Has a lower R value per inch, although it can be even higher than this 4 that we've called out, 3 to 4. It depends on the material density. So EPS has over 1 through over 10 types, and the types are different classifications of material densities of the EPS. So that's why you're seeing a pretty big product density range here. It shouldn't really be used to control bulk water. And the reason we're saying that is the EPS material itself has beads of EPS. It allows for water to sit in the material between the beads, while the water would not penetrate into these beads or sort of cell forms of the EPS. It can sit between these beads, and so it's better. EPS will resultingly hold water. It will function as an air barrier, however, and has a vapor. It has a permeance of 2.5 to 5. You'd find this on your exterior walls and roofs as well. There's also polyisocyanurate, which has the highest R value per inch of the rigid foam boards. If it's foiled, I've used an example of a foil-faced product. If it's foiled, it basically serves as an air barrier, as a vapor barrier. So again, you want to be careful if you use a foil-faced product like this. Again, can function as your air barrier if taped and sealed, and can shed bulk water. So now we are coming up to the blown-in products or loose fill products. Fiberglass is very common, often the most economical choice. It has a varying range of R value per inch. Again, it depends on density, bonded or unbonded, but you're in that same range that we're seeing for our other typical blown-in or open-cell spray foam products, which is in the mid three on an average 3.5 per inch R value. However, as we've already discussed, it will not function to shed any bulk water. It certainly will not function as your air barrier, and vapor freely flows through it as well. That being said, sometimes it is the right choice for your project for restorations, renovations, where you need to blow into stud cavities. That can be the easiest and most reasonable choice sometimes. We most commonly see it on attic floors, blown into attic floors and stud cavities. Mineral wool, which is a byproduct of the slag industry, is a recycled slag product, slag being a byproduct of the steel and copper industries. It can have fairly high recycled content, 60% recycled content and higher sometimes. Has that same R value per range, slightly lower than fiberglass at 3.1 to 3.3 per inch. It won't shed bulk water, it does not serve as an air barrier. It does has sound insulation properties, which a lot of these products do. We're not really talking about sound insulation, but certainly bats, spray foam, fiberglass products have sound insulative properties. Worth mentioning, but not in this context. Won't serve as an vapor barrier as well. Same with cellulose. Cellulose has a high recycled content on the order of 85% often. It's made from paper and other fibers. It's treated often with some borate-based solutions in order to prevent mold and make it insect resistant. Same R value range on the order of 3.1 to 3.5 will not function as an air barrier. Bats, we've got fiberglass, rock wool, blue jeans. Fiberglass has our value range, same as what we've already been talking about. We've already been through this, it not functioning as an air barrier. That's the most important takeaway of this this category of insulation comes in various cavity depths and various densities. Where should you put it? That's a good question. It's quite difficult to get a good bat installation. So given other options that are available, often think you're better off taking a different option. But there are instances where fiberglass bats and bats in general function well. Rockwool bats are not as floppy. So I have seen some compelling installations and claims of installing contractors that it's easier to work with, at least in areas where you don't have penetrations or piping or other stuff going on. And even so, because it is stiffer, it can be easier to work with. At least that's what I have heard said. It won't function as an air barrier, it won't function as a vapor barrier. Again, comes in varying depths. Blue jean bats, it's what we would consider a specialty product, has a high R value per inch. The product densities vary, generally more expensive, although there are some programs that actually are promoting the recycled blue jean product, so there's information to be had online about that. So when would you choose a product like that? Specialty products like, say, blue jean insulation, aircrete, which is a wet applied blown in product, and stone wool, which is not rock wool. It's actually made from volcanic ash, aerogel, hempcrete. All of these, there are a lot of specialty products available. And so when would you choose them? When do you consider them? I would not recommend considering them for an ordinary project. You would consider them when you have a client with special considerations. So maybe they are interested in products that have lower embodied energy, for example, or your clients have chemical sensitivities, so you want to consider products with low VOC content, no formaldehyde. There are special instances when you want to look to specialty products, but for your average project, you're rarely going to turn to these products for your insulation solutions. So just as a wrap up, some of the pros and cons of the various types of insulation with XPS, rigid, foam board. We've lost some of our words here on that. But the XPS has a high R value, will create a thermal break. It can be expensive, both for the material and for the labor if it's not already part of your construction process, and if you don't have a labor force that is familiar with this method of installation. But it's not that complicated. It's just a new piece of the process. Same with EPS, although one of the cons of EPS is that it can hold water. It does create thermal breaks. There are no VOCs with either of these rigid foam board products, so that can be important again in these sort of specialty cases. Blown in is good for its ease of installation. In the context of retrofits, it's often cost competitive. And one of the downsides is that it can settle with time. And also, it does not function as an air barrier. I know I'm beating that horse till past dead, but it's important. Bats, they are inexpensive. Anybody can do it. Almost nobody can do it well. So the con of bats, the biggest con and the thing to watch out for is the quality of installation around a bat. So with that, we are going to wrap up our part 2 of our discussion of insulation, and we'll be back to talk about installation, signs of good installation quality,